In this video, I'd like to talk about the Fourier's law of heat conduction. In heat transfer, the temperature difference is the most important thing. If there is no temperature difference, there is no heat transfer. This is very important. To begin with, total heat flux is proportional to the temperature difference. That means if the temperature difference increases, the heat flux increases too. And also, if the temperature difference is decreased, the heat flux through the heat transfer will be decreased. It is called proportionality between heat flux and temperature difference. Total heat flux is proportional to the area perpendicular to the direction of heat transfer. This is pretty much intuitive that if the area of heat transfer is increased, the total amount of heat will be increased. Also, the heat flux is inverse proportional to the thickness or distance through the heat transfer path. That means if the thickness increased, the total heat flux decreased, and if the thickness decreased, the heat flux is increased. It could be expressed in this way. Let's put temperature difference, distance, and the area all together. Then you have a heat flux Q is proportional to the temperature gradient and the area. And the temperature gradient is dt over dx. So heat flux Q is now proportional to the temperature gradient. Now for the practical purpose, this proportionality is not enough for the precise and the exact measurement using numbers. Therefore, we all know that it is necessary to introduce a coefficient that will make this proportionality to equality. And that coefficient we call is thermal conductivity. With this coefficient, also this coefficient is material property, we now have a Fourier's law of heat conduction in a complete form. Negative sign in front of the thermal conductivity is necessary since the heat flow is the direction of negative temperature gradient. I mean, heat always flows from high temperature to low temperature. And again, if there is no temperature difference, there will be no heat transfer. By utilizing and solving this Fourier's law of heat conduction, we can solve a heat transfer problem and can have a better understanding of heat flow and the temperature distribution. Thank you.